Now I would like to invite 4 young researchers from BME to pitch their work here on stage. After this very short session, everyone who is physically present at the venue will be invited to the lobby for a very exciting lunch. But we will keep going with our online program. All the session will be broadcast all over the building, so you will not miss a bit. So now welcome Zsófia Deme-Bélafi, Department of Building Services and Process Engineering. After her, János Mizsei, Department of Electron Devices. Then András Czmerk, Department of Mechatronics, Optics and Mechanical Engineering comes on stage. And then Josh Davidson, Wave Energy Research Group.
Hello everyone, so welcome to this speech. This is a tricky timing for me because you have already stolen my colleague Miklós. You remember Miklós, who introduced 2 projects of our research group in advance, introducing the whole research group itself. You remember when he was talking about improving the European certification systems for buildings and also an education system for smart buildings. So this is a good reinforcement for Miklós Horváth, our colleague. So let me just go through very quickly what kind of projects what we are working in the field of building energy. We have heard a lot of things today and also yesterday about the importance of energy in buildings. So we did a large-scale smart metering project where we analyzed the smart meter data sets here in Hungary. We had almost 30,000 smart meter data available. In the end, we had 800 meters analyzed and also used advanced clustering methods to come up with building and household types and user types like morning people or villager people or city life youngsters and things like that. So we do a lot in occupant behavior, and also in the second point, we improved a lot the department and also in the country the education of dynamic building performance simulations. And now we use it not only for building level simulations but also for building stock level simulations. And we were talking here, actually they were talking about research supporting policy somewhat directly. Our department was approached by the Ministry of Innovation and Technology to support the advancements of the building code, the building energy code here in Hungary. So we would like to imagine or believe that we have a place to support policy as well, somewhat directly. Of course, building energy here, it's a very applied field, so we are in a better position than many of the other departments here. Third point, so we work and do experiments on low energy heating and ventilation systems. Also, you can see a roll-up from our past PhD student who funded his own startup on phase change material seasonal storage systems. Also, we have 2 test chambers which can be used by the industry and by also our researchers for thermal comfort and indoor air quality tests, and also a heat production lab which is used by industry vastly. And we are tapping into multi-dimensional comfort experiments, so we try to look whether acoustic or visual environment affects our thermal comfort perception, for example. So very exciting stuff, I would say. We desire future collaboration also in national and international research projects. I did this slide a little bit differently than others. I would focus on one horizon topic in this area, in the smarter buildings for better energy performance. This is the call where we are looking for partners and consortium leaders. Also, I would mention that in this topic, there is a potential, I think, which our department and our research group would try to propose, that this very building could be a demonstration site for one of the Horizon proposals, trying innovation techniques and advanced sensor technologies. Also, we have a vast experience in residential renovation and innovation projects here in Hungary in residential buildings, so we can offer them as a demonstration site as well. So please contact us. Our head of the research group had to excuse himself, Tamás Csoknyai, but you can contact me or himself as well. Thanks for the attention.
Okay, so I am János Mizsei from the Department of Electronic Devices of our university, and now I will introduce, I believe very shortly, our groups. You can see here our clean rooms and many other facilities. We can make semiconductor sensors, micromechanical systems, and many different microsystems. But the most important, which is a subject of the present talk, is the thermal electric circuits. So in conventional integrated circuit, we have electrical coupling between gates. And of course, there are some thermal coupling between gates, but this is a parasitic effect. Until now, it was a parasitic effect. But we can use the thermal transport also for creating bits. So the basis of that thermal electric circuits is that transistor. This is a phonon transistor, which consists of a thermally sensitive resistor, which can be switched on by using a heating resistor. So combining a lot of transistors, we can build pretty difficult logic systems, which are a little bit analogous with neurons. So here you can see some examples. How can we build a shift register, different logic gates using that thermal electric effects. And what is more important, that if it is compatible with the conventional CMOS device, I believe it will be a real revolution in that integrated circuits technology. So our vision is that we can integrate our thermal electric logic circuit with a conventional CMOS, and you can see that this is still a growing market. So there is a very nice sentence: nothing beats scaled silicon, but nanotechnology can complement. So we can maybe step behind that red brick wall, which is a technological limit until at that time. So you can see that collaboration we are interested in. I corrected in the recent version, but I could not send it in time. And of course, keywords for Horizon Europe is that advanced materials, semiconductors, and manufacturing technology. Here you can see some patent. This is a PCT, international patent, and there is a Hungarian version also. So if you think that this is a perspective subject, then contact us. Here you can contact us, and I believe we are standing in a very bright and good future. Thank you very much. 10 seconds.
Hi, I'm Josh Davidson. I'd like to introduce the Wave Energy Research Group. So yes, by wave energy, I'm referring to offshore renewable energy and harnessing the power of ocean waves to produce electricity and desalinated water, which might seem a bit strange considering Hungary is a landlocked country. But my background is in offshore renewable energy, and I met a Hungarian, we got married, moved to Budapest, and I was fortunate enough to find a position at BME. So I'm in the Department of Fluid Mechanics, which has a very strong background in CFD. And so I was able to continue my development of numerical wave tanks, which are a digital twin for the ocean environment. And this enables researchers to simulate, evaluate, optimize offshore renewable energy devices. And you can see on the left an example of one of these systems we've simulated. However, there's an adage that the solutions to the problems in your field already exist in another field. And I found that to be true as I started to discover the expertise here at BME. So for example, the acoustics group in our department, we're were investigating noise sources from the rotors and aircraft, and the methods they developed could be very useful to this type of wave energy device, which produces electricity from a spinning turbine as the air is sucked in and out through an orifice as the water level rises and falls. However, the noise from these turbines has never really been investigated since all the expertise has been looking at power production. Another example is collaborating with some colleagues at the Department of Applied Mechanics, leveraging their expertise in nonlinear dynamics on the stability of wave energy converters. So this wave energy converter should move up and down. However, under certain conditions, a nonlinear phenomena called parametric resonance causes large unstable rotations, which causes loss of power production and can be quite dangerous to the system's safety. So we would like to be a conduit between the expertise at BME and knowledge gaps in the field of offshore renewable energy. At BME, there's 36 different engineering departments, and so far I've only collaborated with 2. So I believe there will be other solutions ripe for the picking within the university. So I'm really thankful for initiatives like this competency fair, where I can learn more about the different researchers here, and also by introducing our group. If there are researchers with an interest in this field or may have a solution they think could be relevant, then by all means contact us. On the European side of things, typical consortia in wave energy are usually strong in the core ocean engineering disciplines. However, there is sometimes a need for a special niche expertise on a certain subsystem or topic. So we hope that we can be called upon if we fill those requirements. So in conclusion, wave energy is a very multidisciplinary field, and I believe within the departments at this university there is can exist expertise which can help provide solutions to those problems. Thank you.
So I would like to introduce the Department of Mechatronics, Optics, and Engineering Informatics. So these departments deal with robotics, and I would like to talk about my experience of an H2020 project is running called Trinity. So our department has 3 areas: biomechatronics, robotics, and optics. So, and in robotics, we have researches which are dealing with robots connected with other equipments for measurements, to measure some parameter and evaluate this parameter at the same time, and in some cases to control it and evaluate at the end. We have some developments regarding haptic devices, and we connect a real system to a computer, and we connect as a augmented reality to move or to actuate a real system, and we can see on the screen how would the system behave virtually. Probably if we turn a pin, we could see how we stir a coffee. So and this simulation is connected. So and because we have these demos, and we joined to a community in European field. It calls and we built we brought a proposal, and we ran each 2020 project, and it deals with agile production of manufacturing to develop the digitalization of SMEs, and it has our community has 3 legs: robotics, IoT, and cybersecurity. We know that's very important, the cybersecurity itself. And what are the results of this H2020 project from my point of view? The SMEs needs developments in robotics and in AI at the same time. But the gap, as Massimo said before, it's quite huge. And we have to have the connection, universities, research areas, and industrial partners. So it has to be some brokerage institution like FIEC, and thank you very much for organizing this event, because this can make a bridge between two separated areas. And it needs competence from the industry, from the universities and research centers, and the trust from the industry. And then can make a connection. So that's the experience. And thank you very much. And I think you have to make your view wide, and to look for digital access points to upload your research experience to get connections more easy to industry. Thank you very much.